All right, let's solve a second question in chapter 7. This time it is question 142. So in question 142, we are given this diagram. There's three capacitors, and we are asked to find the equivalent capacitance. And we're given some value. We're told that C1 is equal to 1 microfarad, C2 is equal to 5 microfarad, C3 is equal to 8 microfarad. You will see the technique here are nearly identical to when we were solving mixed circuit in the previous chapter. All right, so the first thing we want to do is we can take these two, C1 and C2, they are in series, and we can combine them to form one equivalent capacitor. So basically, the rule are reversed when talking about capacitors. So the formula for the parallel circuit in the previous chapter is the same as the capacitance in series in this case. So when we combine the first capacitor and second capacitor, we use that formula, and we get that the capacitance is 0.83 microfarad. Now we are at a point where we have two capacitors in parallel. Well, now they act like in series for the resistance. So we simply add them, 8 plus 0.83 microfarad. So we get back to one capacitor, and we got an equivalent capacitance, 8.83 microfarad. So let's, just as an example, by the way, if you need to erase anything, pause the video now. I need the top part to draw an example of here. So let's say we have a capacitor, and we're going to use the equivalent capacitor here, 8.83 microfarad. And let's say we have 20 volt here. Well, if we want to find the charge here, so remember capacitance is equal to charge divided by voltage. We have capacitance, we want to find the charge, so it will be C multiplied by V is equal to Q, and we'll get Q is equal to 1.766 multiplied by 10 power minus 4 coulomb. All right, and the same logic could be applied if we wanted to find the charge on each capacitor. We could move our way back up basically and use the intermediary capacitance on each of the step to calculate the charge on each capacitor. All right, that's it for question 142. We're going to talk about energy in a capacitor in the next video, and then after we're switching to charging and discharging a capacitor. All right, see you in the next video.